Well, pre-calculus classes, again, good morning, good afternoon, or good evening. We will go ahead and go into the second set of the 5.5 notes. Probably the best news for today, there will not be any period change questions with these. You may want to have a unit circle, possibly even your identity sheet handy. I am going to refer to both of those, certainly as we go through this set of notes. One of the things we're going to look at today, we're going to do some factoring with trig functions. So, to get started here, the first one says find all solutions in the interval 0 to 2 pi for 2 sine squared x minus sine x minus 1. Well, for this, we are going to have to split the middle. So what we're going to do, take a times c, so we're looking for what multiplies to negative 2, what adds to negative 1. Well, our combination that will do that for us is negative 2 and positive 1. So I am going to split my middle term into negative 2 sine x plus sine x, and then minus 1 equals 0. Now from here, we will factor by grouping. Out of 2 sine squared minus 2 sine x, I can factor out a 2 sine x, leaving sine x minus 1. Out of sine x minus 1, there really the only thing you can factor out is technically a positive 1. I do like to actually write that as your placeholder. So our two factors, sine x minus 1 equals 0, and 2 sine x plus 1 equals 0. Again, what we're going to do for these is go ahead, isolate our trig function. So sine x equals 1. For this one, subtract 1, divide by 2. Sine x equals negative a half. So again, what we're going to do on our unit circle, first, where does sine equal 1? Well, that's at pi over 2. Then, where does sine equal negative a half? Well, there are two locations there. Right here is 7 pi over 6. Directly across is 11 pi over 6. Again, we're looking for where does y equal negative 1/2, since it's sine. So for this one, between 0 and 2 pi, we don't have to worry about the plus 2 and pi because these are the only solutions over the interval 0 to 2 pi. And again, one thing that's really nice here, without a period change, also makes the problem a little bit simpler. All right, so example 2, find all solutions. Again, 0 to 2 pi for cotangent x cosine squared x equals 2 cotangent x. The one thing that we want to emphasize here, and this is kind of how we have written this, do not divide by cotangent. It looks like a good idea to do that. You cannot divide by variable terms when you're solving. You cannot divide by a trig function with a variable. So what we're going to need to do, move this over and factor. So to move that, I am going to subtract the 2 cotangent over. Now, we have two terms. We can factor out our GCF. Our GCF, greatest common factor, will be cotangent x. And from there, we have cosine squared x minus 2 equals 0. Now, from here, cotangent x equals 0, cosine squared x minus 2 equals 0. Well, for cotangent, again, just this is where I was saying you might want to have your identity sheet handy. Cotangent, cosine over sine. So we are looking for, on the unit circle, where does cosine over sine equal 0? Well, there are two spots. Cosine over sine, 0 over 1 would be 0 at pi over 2, and 3 pi over 2. 0 over negative 1 is also 0. All right, so for the next one, now we have cosine squared x minus 2 equals 0. Go ahead and solve. Now, when we do that, cosine x equals positive and negative radical 2. Now, for this problem, here is where radical 2, be careful, is not on the unit circle. Now, we're going to talk about a couple of different things for this. First off, if you remember domains and ranges for cosine. Well, the domain of cosine is negative to positive infinity. Your range for cosine is going to be the issue here. A standard cosine equation has a range from negative 1 to positive 1. Well, the square root of 2, just so we have that as a point of reference, is 1.4. So that is actually outside of the range of cosine, sending with the negative. Now, another option here, if you weren't noticing that, just kind of right off the bat, if you tried to now take the inverse, because again, this is not a unit circle value. Well, if I take the inverse cosine of that, I get domain error. So the good news for this question, this part is outside of our domain. So our only two solutions are pi over 2 and 3 pi over 2. One of the things that you will find as we factor problems involving trig functions is that it's not uncommon when you actually try to work with factors of either cosine or sine that you end up with values outside of the range. So that's something to just kind of be aware of. Now, the next question here. Find all solutions for 2 cosine x plus sine 2x equals 0. Well, for this one, here is where what's going to have to happen now. 2 cosine x sine 2x. Unlike the last one, we do not have a greatest common factor. We have two different trig functions. So what I am going to do is look up in section 5.2 and just refer to one of our, I guess it's actually 5.3, one of our double angle formulas. And that is the sine of 2 theta is 2 sine cosine. So this is going to become 2 cosine x plus 2 sine x cosine x equals 0. Now we have a greatest common factor that we can use here, and it's going to be 2 cosine x. So when you factor 2 cosine x out of itself, leaves 1 plus sine x equals 0. Now from here, set each of your factors to 0. Divide the 2, cosine x equals 0. Where again does cosine equals 0? Well, we actually talked about it in the last problem. One of the spots is at pi over 2. One of the spots is at 3 pi over 2. Now, be aware here, find all solutions. So x will equal pi over 2 plus 2n pi. X will equal 3 pi over 2 plus 2n pi. Now for this one, sine x equals negative 1. Where does sine equal negative 1? Well, it's down here. Don't be surprised also with some of these questions when you are factoring with exact values that, well, because we already have that answer listed, we don't need to list a repeat answer. So that is, or those are, I guess I should say, your answers for this one. Now, example 4, we do run across another issue here, which kind of is even included in the directions, where we have 2 sine squared x plus 3 cosine x minus 3 equals 0. It does tell us rewrite with a single trig function. Well, in order to do that, we are going to need to use Pythagorean identity. The sine squared we will turn into 1 minus cosine squared. Distribute. And now we can combine some like terms. So negative 2 cosine squared x, 3 cosine x, 2 and negative 3 is negative 1. Now, from here, one of the other things that I'm going to do, I don't really like to factor. If my a value is negative, I'm just going to multiply the entire problem by negative 1. 2 cosine squared x minus 3 cosine x plus 1 equals 0. Again, the reason we can do that, since this side is equal to 0, basically all our signs simply switch. So now we're looking for what multiplies to 2 and adds to negative 3. Well, that will be negative 2 and negative 1. So we are going to split the middle. 2 cosine squared x minus 2 cosine x minus cosine x plus 1 equals 0. Now, we are going to, again, factor by grouping. Out of 2 cosine squared minus 2 cosine, my GCF there is 2 cosine x, leaving cosine x minus 1. Out of these two, I can factor out a negative 1, leaving again cosine x minus 1. So our two factors, cosine x minus 1 will equal 0, and 2 cosine x minus 1 equals 0 as well. So isolate our trig functions. Cosine x equals 1. Cosine x equals 1/2. And now, looking at our unit circle, where does cosine equal 1? At 0. Where does cosine equal 1/2? At pi over 3 and 5 pi over 3. So those are our 3 answers for this question. So, other than that, one final question for this portion of the notes. Cosine x plus 1 equals sine x. Here we are saying x needs to be an element of the set 0 to 2 pi. That's just saying from 0 to 2 pi using set notation instead of just interval notation only. Now, from here, we do run into an issue. We can't do any substitutions. You cannot use a Pythagorean identity to get these into a single trig function. And from here, what we are going to do is, as long as we keep each side balanced, we are going to square both sides. Now, when I do that, I am going to write out this side. The right side's just going to become sine squared x. Now, for this, cosine squared x plus, when I FOIL it out and combine like terms, 2 cosine x plus 1 equals sine squared x. Now, from here, kind of like the problem we just did, I am going to have to use a Pythagorean identity substitution. Sine squared is 1 minus sine squared, or cosine squared, excuse me. And now I can move my like terms over. Now the nice thing that does happen here, when I do add this over, I get 2 cosine squared x plus 2 cosine x. Now what is nice, the 1's cancel. Actually makes that a little easier. We do not have to split the middle. We can now simply use a GCF of 2 cosine x, which will leave cosine x plus 1. So 2 cosine x equals 0, cosine x plus 1 equals 0. So we're looking for, when you divide the 2 over, where does cosine equal 0? I know kind of a recurring theme on several of our examples. Cosine is 0 at pi over 2 and 3 pi over 2. Where does, when you subtract, cosine equal -1? Well, cosine equals -1 at pi. So those are our 3 solutions from 0 to 2 pi. Again, none of these problems had period change today, so that does make things a little bit easier. There is an assignment again on Pearson for this portion of 5.5 as well.